Alright, so I have a triangle. What type of triangle did I ask you to draw? You can't see it. And what markings do you make on a equilateral triangle? A line where? Okay. This tells me the sides are congruent.
Yeah.
Okay. What do you know about the angles, class? They're all the same. What is it? 60. Then I asked you to draw a perpendicular bisector, or the altitude. The altitude is the height of the triangle inside the triangle. And a perpendicular bisector basically means it is a bisector cutting the angle in half and cutting the side in half. So this angle now becomes what? 30. Let's say I just make up a number such as 2. If this side length is 2, class, that means that this one has to be 2, and this one is 2. But if I have a perpendicular bisector, this side length now is 1. This shows you that the special right triangle is called a what? Tell me the angles.
30, 60, 90.
30, 60, 90. This is a special right triangle in which it tells you that across the 30, the smallest angle is the smallest side. That's 1. Across the right angle is 2, and across the middle angle is this side length, which you can use Pythagorean theorem, and that one's going to be radical 3. So if you need the shortcut, it's 1x, 2x, x radical 3, and you can put in any side length there. So a student was asking a question, while making these reference angles, how do you get those side lengths? They come from this idea. Let's do the square. Class, what did I ask you to draw in your square? It's a diagonal. What symbols do you put for squares? A line where? All the sides. So a square has 4 congruent sides. Anything else? 4 right angles. That basically means that this diagonal is also an angle bisector. Well, if this is 90, that means this one has to be 45, and this one will be a 45. Let's just say I make up a number. What number do you think I'm going to make up? 1. If this is a side length of 1, what will this be?
1.
You can use Pythagorean theorem to find the second side, a third side of a right triangle. That will become radical 2. So that means in a 45, 45, 90 triangle, the shortcut that you have is 1x, 1x, x radical 2. And this might help you understand the reference angles in a right